welcome to our deep dive, all about advanced computer networks.
Yeah.
We're going to be using a university-level ebook on this topic to really try to help you understand how the internet works.
Uh-huh.
And, really understand how it works, not just like surface level,
Right. Right.
browsing websites and things like that, but like the intricate systems that are making it all possible.
Yeah, exactly. We'll be going from the actual wires and cables all the way up to, how you get to see a website or send an email.
Yeah, just fascinating stuff.
Yeah.
Okay, so let's start with the basics here.
Okay.
What exactly is a computer network?
Right.
The ebook defines it as a system of connected devices sharing data and resources.
Mm-hmm.
Sounds pretty simple, right?
Yeah, it does.
When you think about it.
But it's not.
It's not.
When you start to think about it, almost everything we do relies on networks, these days, making money out of an ATM, streaming a movie.
Streaming music.
Yeah, sending a text message. All of that relies on computer networks.
Oh, yeah, for sure.
And it's interesting to see, these networks actually first evolved from basic systems used by the military back in the late 1950s.
Wow.
And now we have the super complex systems today.
Yeah, it's really amazing how we take it for granted, right?
We do.
One thing I found really interesting in the ebook was this idea of overlay networks.
Uh-huh.
So it's not just like one giant web out there, right?
Yeah,
like
right.
my company's network, it's like kind of layered on top of the internet.
Yeah.
It's all these interconnected networks all working together.
That's a great point. And it's this layering that allows for some pretty incredible things,
Right.
Virtual operation, integration on a massive scale.
Uh-huh.
The ability for networks to quickly respond to changing demands.
Right.
And of course, a really big one, security.
Yeah, security is a big one.
How do we keep all this safe?
Right. So we've established we're surrounded by all these, interconnected devices.
Yeah.
But how do they actually talk to each other?
Right.
How does that all work?
So this is where the OSI model and the TCP/IP model come in.
Okay.
And the ebook describes these as structured ways for devices to communicate.
Okay.
So you can think of them as language rules for devices.
Uh-huh.
Without these rules, they'd just be sending random bits of information back and forth.
Right.
And nothing would ever get done.
So gibberish, basically.
Yeah, gibberish.
Okay.
So the OSI model is a really clever way to break down this complex communication process, into smaller chunks. And it does this using 7 layers.
Okay, so like a 7-step process.
Yeah, a 7-step process for how devices communicate.
Got it.
And each layer has its own specific function.
Okay.
So, for example, we have the physical layer that deals with the actual hardware,
right.
the cables and signals.
Okay.
But then, on the other hand, you have the application layer. And this is the layer that you see as the user.
Okay.
The websites, the emails, the apps that you use every day.
Oh, okay. So the OSI model basically takes us from the physical signals traveling through cables all the way up to the application I'm looking at on my screen.
Exactly.
Right.
And while TCP/IP is, a bit more streamlined than the OSI model, it still plays a crucial role in making the internet work.
Okay.
Yeah.
So the ebook really digs into this physical layer.
Yes.
Calling it the foundation of network communication.
It is.
It explains how data is actually converted into electrical signals that travel over wires or wirelessly.
Right. And we can't forget about noise.
Noise.
So, imagine static on a phone call.
Okay.
That's noise interfering with the signal.
Right.
Well, the same thing can happen with data as it travels over a network.
So like a weak Wi-Fi signal is just noise.
Exactly.
Okay.
Understanding this can actually help you troubleshoot network problems in real life.
That's a really good point.
Yeah.
Okay, well, let's talk about Ethernet then.
Yeah.
This is like the tried and true standard for wired networks.
Yeah, pretty much everyone's heard of Ethernet.
Right.
And the ebook highlights its speed and reliability. It's been around for a long time.
It has.
And it's only getting better. They're even talking about this new technology called Ethernet APL, which is even faster and more robust than, regular Ethernet, especially for industrial settings.
That's really cool.
Yeah, it's pretty amazing how quickly the technology advances.
It is.
Yeah.
Okay, so moving up then to the network layer.
Okay.
The ebook explains this layer is responsible for getting data packets to the right place.
Right. So it's basically like a postal service for the internet.
Okay.
You can think about IP addresses as the unique identifier, like a house address.
So every device connected to the internet has its own address.
Exactly.
Okay.
And just like a postal service uses addresses to deliver mail, The network layer uses IP addresses to make sure data packets get to the right place.
So my data packets have addresses, but how do they actually like navigate this massive network?
Right. That's where routing protocols come in.
Okay.
So routing protocols are like traffic guides for the internet.
Uh-huh.
They consider things like network congestion, available paths,
Okay.
to determine the best way to get that data to its destination.
Wow. So they're constantly like analyzing the network and choosing the best route for each packet.
Exactly. And there's different types of routing protocols too.
Okay.
Each with its advantages and disadvantages.
Okay.
So for example, static routing, it's really simple to set up,
Okay.
but it's not very flexible.
Gotcha.
Dynamic routing, on the other hand, is much more adaptable,
Uh-huh.
but it requires more resources to manage.
Okay. So it's all about picking the right routing protocol for your needs.
Exactly.
What happens if a data packet gets lost or corrupted along the way?
That's a great question.
Yeah.
That's where the transport layer comes in.
Okay.
This layer is like a quality control check, making sure the data arrives in the right order. Without any errors, you can think of it as a really meticulous editor,
Okay.
carefully proofreading a document before it gets sent out.
Got it.
Yeah.
Okay. So this layer ensures that all the data arrives intact and in the right order.
Exactly.
Okay. And are there like specific protocols for this too?
There are two key protocols at this layer,
Okay.
TCP and UDP.
TCP and UDP. I've heard of those.
Yeah, so TCP is like a registered letter.
Okay.
It guarantees delivery and accuracy.
Uh-huh.
But on the other hand, UDP is more like a postcard.
Okay.
So it's faster and more efficient,
Right.
but, it doesn't guarantee that everything will arrive perfectly.
So like TCP would be used for like online banking where accuracy is crucial.
Exactly.
And UDP would be fine for something like streaming video.
Yeah, where a little bit of data loss isn't a big deal.
That makes a lot of sense.
Yeah. So again, it depends on the application and how important data accuracy and reliability are.
This is all fascinating stuff.
It is.
Okay, so we talked about the foundations of how networks operate,
Yeah.
but I kind of want to shift gears a little bit now and talk about some of the specific protocols
Okay.
that power, all the internet services that we use every day.
Yeah, the ebook dives into this.
Yeah, it says there's so much more to the internet than just websites.
Oh, absolutely.
Yeah.
There's a whole world of protocols working behind the scenes.
So let's talk about some of those then.
Okay, well, one of the big ones is DNS.
DNS.
Or the domain name system.
Okay.
So you can think of this as a giant phone book for the internet.
Okay.
It translates human-readable domain names, like google.com,
Right.
into numerical IP addresses that computers can understand.
So every time I type in a website address, DNS is working to translate that into a numerical IP address.
Exactly.
Okay.
And without DNS, we'd be memorizing long strings of numbers to visit our favorite websites.
Yeah, that would not be very user-friendly.
Definitely not.
What other essential internet protocols are there?
So another important one is MIME,
MIME.
or multi-purpose internet mail extensions. Okay. And MIME allows us to attach files to emails.
Oh, okay.
And use special characters,
Right.
It's pretty much the standard for all internet email now.
Really? So almost every email I send or receive relies on MIME.
Almost every single one.
Wow.
Yeah.
Okay.
And then, of course, there's HTTP,
HTTP.
Hypertext Transfer Protocol.
Okay.
And this is responsible for loading web pages. It's the backbone of our online interaction.
So DNS helps us find websites.
Yes.
MIME lets us send fancy email.
Uh-huh.
And HTTP loads those web pages so we can see them.
Exactly.
There's a lot going on behind the scenes.
There is a lot going on, but we're just getting started.
Wow.
There's tons of other protocols that power all sorts of internet services.
This is all so fascinating. I had no idea there was this much complexity behind something we use every single day.
Well, it really is a testament to human ingenuity.
Yeah.
And speaking of technology that's, become so integral to our lives.
Yeah.
Let's talk about mobile computing. So the ebook dedicates an entire chapter to this, highlighting its explosive growth,
Right, like mobile devices have become almost like extensions of ourselves these days.
Yeah.
And just like computers, they rely on networks to function.
Absolutely. And understanding how these networks operate can really help you make informed choices about your mobile experience.
So what are some of the key things to consider when it comes to mobile networks?
So first off, you have different types of mobile devices. You've got laptops, smartphones, wearables.
Right.
And each device has its own unique characteristics and challenges.
Okay.
When it comes to network connectivity.
Right.
So designers have to think about things like the size of the device, the power source, the
Mhm.
operating system,
Right.
what type of connectivity it needs.
It's amazing how much goes into making these devices work seamlessly.
It is.
Yeah.
And then you have the variety of the networks themselves,
Uh-huh.
wireline ad hoc networks.
Hmm.
You know, each type has its own strengths and applications depending on the situation.
Right. And of course, we can't forget about the future of mobile networks.
Yeah.
Like 5G Li-Fi,
Yeah.
using light to transmit data.
It's an exciting time to be following mobile computing, you know?
It is.
Those technologies are really pushing the boundaries of what's possible.
Absolutely.
Yeah.
Well, since we're on the topic of wireless communication, let's dive into that a little bit more.
Oh, okay.
The ebook goes into quite a bit of detail here,
Yeah.
highlighting all the different wireless technologies that are available.
It's a fascinating field, you know?
It is.
Did you know that wireless communication actually uses electromagnetic wave to transmit data,
Really?
just like radio or TV signals?
Oh, wow. So it's using the same principles as those old school technologies.
It is pretty clever.
That's cool.
And from there, we have this amazing range of technologies, you know, Zigbee for smart home automation,
Okay.
Bluetooth for connecting devices, Wi-Fi for internet access, NFC for contactless payments.
Right.
You know, each technology has its own strengths and specific applications.
There's like a whole ecosystem of wireless technologies all working together.
It is to create this truly connected world that we live in.
Yeah.
And one thing the ebook highlights is the ongoing push for like global standardization in wireless communication.
Okay.
This is really important because, you know, it ensures that devices can seamlessly connect no matter where you are in the world.
Right, especially as we become increasingly reliant on mobile devices and wireless networks.
Yeah, absolutely.
Well, this has been great.
Yeah.
I think we've covered a lot of ground in this first part of our deep dive into advanced computer networks.
I think so too. You know, we went from the basic definition of a network all the way to the intricate details of routing protocols,
Right.
wireless technologies,
Yeah.
and even a glimpse into the future of connectivity.
Yeah, and that's just the beginning.
Exactly.
We'll be back in part 2 to explore even more fascinating concepts, including security issues in wireless networks
Yes.
and the rise of software-defined networking.
Stay tuned.
It's going to be good.
It is.
All right, thanks. Welcome back to our deep dive into advanced computer networks. In the first part, we covered a lot, the foundational concepts of networking.
We did.
Now let's delve a little deeper into some of the challenges and innovations that are shaping the future of connectivity.
Absolutely.
So we talked about wireless communication and, how amazing it is.
Yeah.
Our devices can connect using invisible waves and all this.
Yeah, it's pretty amazing.
But the ebook also raises some important questions about the security of wireless networks.
It does.
Because they are inherently, more vulnerable than traditional wired networks. Because that data is being transmitted through the air.
Right.
It's easier for somebody to intercept or disrupt those signals.
It is.
Yeah.
It's kind of like, having a conversation in a crowded room. Anyone could be listening in.
Yeah, that's a good analogy.
And the ebook highlights 3 main common threats to wireless networks.
Okay, let's hear them.
So you have denial of service attacks.
Denial of service attacks, those sound scary.
They can be.
What exactly happens there?
So imagine a website being flooded with so much traffic that it crashes.
Oh, wow.
And this prevents legitimate users from accessing it.
Okay.
That's essentially a denial of service attack.
So it's basically like blocking the entrance to a website with a mob of virtual people.
You got it.
Wow, okay.
And then you have spoofing and session hijacking.
Spoofing and session hijacking.
Yeah, where attackers disguise themselves as legitimate users to gain access to sensitive data.
So they're basically stealing someone's identity to break into their accounts.
Exactly.
Okay, and the third one?
And then the third one is eavesdropping.
Eavesdropping.
Which is pretty much what it sounds like. Unauthorized individuals intercepting data as it's being transmitted.
Okay, that's unsettling.
It can be.
So what can we do to protect ourselves from these types of threats?
Well, the ebook really stresses the importance of properly configuring your wireless network.
Okay.
So things like, activating strong authentication, using encryption, and setting up access control mechanisms.
So it's kind of like locking your doors and windows to deter burglars.
Exactly.
Yeah.
So while early security methods, like using simple passwords and MC address filtering offered some basic protection, it's just not effective against modern threats.
Okay.
I remember seeing wired equivalent privacy
Right.
on like older routers.
Yeah.
So WP was kind of a step in the right direction. It used encryption keys
Okay.
to secure the communication.
Right.
However, it's proven to be pretty vulnerable to hacking.
Okay.
And the ebook recommends upgrading any devices that are still using WEP.
Got it. So strong security settings keep our devices up to date.
Yes.
That's all crucial.
Absolutely.
So this brings us to kind of an interesting development in networking.
Yeah.
Software-defined networking, or SDN.
SDN, that's a good one.
Yeah.
Yeah.
The ebook describes this as a major shift away from traditional hardware-based networks.
It is.
So tell me about SDN.
So SDN is all about using software to control the network
Okay.
rather than relying on dedicated hardware
Right.
like routers and switches.
Okay.
So you can think of it as like having a central brain directing all the operations.
Okay, so instead of having these individual devices making decisions about where to send data, you have this central controller.
Yeah, a centralized software controller
Got it.
that manages the entire network.
Okay, so how does SDN actually work then? What makes it so different from traditional networking?
So in a traditional network, the control plane and the data plane are very tightly coupled.
Okay.
The control plane, which determines, the best paths for data, it's actually embedded in the hardware itself.
Okay.
But in SDN, those planes are separated. So the control plane becomes this centralized software-based controller.
Okay.
And the data plane, the actual forwarding of data packets, remains in the hardware.
So the control plane is like the brain making decisions.
Yes.
And the data plane is like the muscles carrying out those decisions.
Perfect analogy.
I like that one.
And it's this separation that gives SDN its flexibility.
Okay.
So network administrators can now make changes, allocate resources, optimize traffic flow,
Okay.
all from a central location without having to physically reconfigure the hardware.
Right, so no more running around to different routers and switches every time you need to make a change.
Exactly.
That sounds really efficient.
It is.
SDN also offers advantages in terms of security, right?
It does, because now you have this centralized view of the entire network,
Okay.
which gives administrators much better visibility into potential threats.
So you can quickly identify compromised devices.
Exactly.
Things like that.
And isolate them, define secure pathways, and implement security policies across the entire network.
Wow, it sounds like SDN could be a real game changer for businesses,
It really does have the potential.
especially as the world embraces cloud computing and edge computing and all these things.
The Internet of Things.
Right.
Where fast, flexible, and secure connectivity is essential.
So SDN is really poised to play a huge role in all this.
A huge role.
Well, with all this talk about high-level concepts, I'm kind of thinking about the actual physical components that make networking possible.
Right. You can get lost in the abstract world of data and protocols.
Yeah.
But ultimately, it all boils down to physical infrastructure.
Right. And the ebook mentions these things called points of presence, or POPs.
DOPs.
Yeah, I don't really know what they are.
Yeah, so think of POPs as physical locations
Okay.
where different networks interconnect. So they're like hubs or gateways that connect, your local network to the wider internet.
So it's like a giant junction box where all the data cables come together.
You got it.
Okay.
So your internet service provider, your ISP, they'll have multiple POPs distributed throughout their service area.
Okay.
And these POPs house all the high-speed, telecommunications equipment
Right.
that directs the traffic
Okay.
between different networks.
So the more POPs an IFP has, the better their coverage and capacity.
Generally speaking, yes.
What about the protocols used at these POPs?
Right.
The ebook mentions something called Post Office Protocol, POP3.
POP3.
Yeah, that sounds familiar.
So POP3, along with IMAP, they're protocols that are used for email retrieval.
Okay.
So, SMTP is used for sending emails, but POP3 and IMAP, they're responsible for downloading those messages from the server to your device.
Okay, so POP3 is like going to your physical mailbox and collecting your mail.
That's a good way to think about it.
You download all the emails from the server to your device.
Yes. And with POP3, your emails are then stored locally. Okay.
On your device.
Right.
Which means you can access them even when you're offline.
That's convenient.
It is.
And what about IMAP then?
So IMAP is more like having a virtual mailbox.
Okay.
So your emails are stored on the server.
Okay.
And you access them through your email client.
Got it.
So this lets you view and manage your messages from multiple devices without having to download them each time.
Okay, so with IMAP, my emails are always synced across all my devices.
Exactly.
Okay, that makes more sense.
Yeah. And you can also organize your messages into folders,
Right. Yep.
search for specific emails much more efficiently.
So it sounds like IMAP is probably the better option.
For most users, it is.
Okay.
But, both protocols have their pros and cons,
Right.
depending on your individual needs.
Right. Okay. So we've discussed POPs, email protocols, even some of the security challenges of wireless networks.
But yeah.
What other kind of network advancements are out there?
So the ebook talks about ad hoc networks.
Ad hoc networks. Yeah. And these are essentially self-organizing networks that don't rely on a central infrastructure.
I think we touched on these briefly before.
We did.
How do they work again?
So ad hoc networks are created when devices connect directly to each other,
Okay.
forming a temporary network without the need for a central router or access point.
Okay.
Imagine a group of people forming a circle to share information rather than everyone speaking through a designated leader.
Okay, so each device is both a sender and a receiver of data.
Exactly.
Okay.
And it's this decentralized structure that makes ad hoc networks really flexible and adaptable,
Okay.
especially in situations where, traditional infrastructure is unavailable or impractical.
The ebook says that these early ad hoc networks were mainly used for military applications.
Yeah, because their ability to operate in these challenging environments, and rapidly establish these communication links made them really ideal for tactical operations.
So like if a group of soldiers needed to communicate in a remote area
Exactly.
and they didn't have access to, the internet or cell towers or whatever,
They could quickly and easily share critical information
using an ad hoc network.
using an ad hoc network.
Okay, that's really interesting. So how have these ad hoc networks kind of evolved over time?
So the rise of wireless technologies like Wi-Fi and Bluetooth gave ad hoc networks a major boost.
Okay.
Suddenly it became much easier for everyday devices to connect directly with each other.
Yeah, I remember using ad hoc mode on my laptop to connect to my phone.
That's a perfect example.
Yeah, to share files when I didn't have Wi-Fi.
Yeah.
Okay, cool.
And as mobile devices, became more powerful, more widespread, a new type of ad hoc network emerged.
Oh.
Mobile ad hoc networks, or MANETs.
MANETs.
What makes them different?
So MANETs are specifically designed to handle the complexities of mobility.
Okay.
As devices move around.
The network structure is constantly changing.
Right.
So these MANET protocols, they can adapt and maintain connectivity on the fly.
So they're kind of like self-healing networks.
Exactly.
Cool.
And they're used in a lot of different fields, disaster relief,
Okay.
where communication infrastructure might be damaged.
Right.
Environmental monitoring,
Uh-huh.
where sensors need to collect and transmit data.
Okay.
Even gaming.
Really?
Yeah.
Wow, that's really interesting.
And then the ebook also highlights some other types of ad hoc networks.
Okay.
Vehicular ad hoc networks.
Vehicular ad hoc networks, so like cars talking to each other.
Exactly.
MANETs.
Yeah. So imagine, cars being able to share information about their speed, their location, potential hazards.
Wow.
This could lead to, a much more intelligent transportation system.
Right. Fewer accidents, less congestion.
Exactly.
And
this is an area of active research and development.
So we could have cars that are talking to each other to prevent accidents.
Potentially, yes.
That's a lot.
And then you also have flying ad hoc networks.
Flying ad hoc networks.
Or FANETs, used for communication between drones.
Oh, wow. That sounds like something straight out of a sci-fi movie.
It does.
What are FANETs used for?
So FANETs are used in a wide range of applications, military operations, search and rescue, aerial photography package delivery.
So these drones are communicating with each other to coordinate their movements.
Exactly.
Wow.
It's pretty amazing technology.
It is. It really seems like the applications for ad hoc networks are limitless.
They are pretty limitless, and as drone technology continues to advance, we can expect FANETs to play an even more prominent role in our lives.
This is really fascinating stuff. Ad hoc networks are really evolving at an incredible pace.
They're pushing the boundaries of what's possible with wireless communication.
Absolutely.
And, with the rise of the Internet of Things, where billions of devices are connecting and communicating, the importance of ad hoc networks is only going to increase.
Yeah, for sure. Well, I think we've covered a lot of ground here in the second part of our deep dive. We explored the security challenges of wireless networks. We talked about software-defined networking.
Yeah, and we witnessed this remarkable evolution of ad hoc networks.
Absolutely, and there's still so much more to explore.
There is.
In the final part of our deep dive, we're going to wrap up our journey
Okay.
by examining some of the cutting-edge trends in networking,
Oh, cool.
including the integration of artificial intelligence
Ooh, AI.
and the quest for even faster and more secure connectivity.
I can't wait.
Stay tuned.
It's gonna be good. All right, thanks.
Yeah, thanks.
Welcome back to the final part of our deep dive into advanced computer networks. We've covered a lot of ground, from the basic building blocks of networks to the complexities of security, the evolution of wireless technologies.
It's been quite a journey. It has been. And in this final part, we're going to explore the cutting edge of networking.
Yeah, the innovations and trends that are shaping the future of connectivity.
The future. I'm ready.
So what?
Okay, the ebook hints at some really mind-blowing developments. What's first on the agenda?
Well, one trend that's really impossible to ignore is the increasing integration of artificial intelligence.
AI.
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 Like the stuff we see in the movies.
Not quite that advanced.
Okay.
But AI is rapidly changing the way networks are designed, monitored, and optimized.
How so?
Well, you have to think about it. Networks generate massive amounts of data.
Right.
Far more than any human could ever analyze effectively.
So AI is stepping in to help us make sense of all that data.
Exactly. AI algorithms can analyze network traffic patterns, identify anomalies,
Okay.
and even predict potential problems before they occur.
So AI could actually help prevent network outages
It could.
and improve performance.
Yes. And it can also be used to automate tasks like network configuration.
Security monitoring, even customer support.
Wow. It really seems like AI has the potential to revolutionize network management.
It does.
Okay, so what else is on the horizon for networking?
Well, the quest for speed never ends.
Right.
We're constantly trying to push the boundaries of how quickly we can transmit data.
Faster internet. Sign me up.
Right.
What are some of the technologies driving this need for speed?
So we talked about 5G earlier in our deep dive,
Uh-huh.
and 5G networks are designed to deliver, significantly faster speeds, lower latency,
Okay.
greater capacity.
Than previous generations.
Exactly.
And 5G is being rolled out in a lot of parts of the world now, right?
It is, but researchers are already looking beyond 5G,
Wow.
exploring 6G and even 7G.
6G and 7G.
Yeah.
What will those be like?
Well, think even faster speeds,
Yeah.
near instantaneous communication,
Wow.
and the ability to connect billions of devices seamlessly.
That's mind-blowing. It's hard to even imagine.
It is.
But what about security? With all this speed, will these networks be more secure?
Well, security is always a top priority.
Okay.
As networks become faster and more complex,
Right.
the potential for attacks increases.
Makes sense.
Right.
What are some of the security challenges then?
And solutions being explored.
Yeah.
So one area of focus is on improving encryption methods,
Uh-huh.
to safeguard data as it travels across these networks.
Okay.
And one really fascinating field is quantum cryptography.
Quantum cryptography.
Yeah, it leverages the principles of quantum mechanics
Okay.
to create encryption keys that are virtually unbreakable.
So it's like a secret code that only the sender and receiver can understand.
Exactly.
What else?
Another area is developing more sophisticated intrusion detection and prevention systems.
Okay.
These systems use AI and machine learning to analyze network traffic, identify suspicious activity,
Okay.
and automatically block or mitigate those threats.
So it's like having a digital security guard that's always patrolling the network,
I got it.
looking for trouble.
Always on guard.
I like that.
And then, as networks are becoming increasingly interconnected
Right.
and reliant on software, the importance of software security is also paramount.
Right, because a vulnerability in the software could compromise the entire network.
Exactly.
Yeah.
So developers are focusing on, creating more secure software, using techniques like secure coding practices, code reviews, and penetration testing.
So trying to find and fix vulnerabilities.
Exactly, before they can be exploited.
It's reassuring to know that all this effort is being put into making our networks more secure.
It is.
Well, this has been an incredible journey.
It has.
I feel like we've gained a whole new appreciation for the complexity and the ingenuity behind these networks that power our digital lives.
It is remarkable when you stop and think about it.
It is.
Yeah.
So what's the one key takeaway you'd like our listeners to remember from this deep dive?
I think the biggest takeaway is that networks aren't these static entities.
Yeah.
They're dynamic, evolving systems
Right.
that are constantly being shaped by new technology,
Yeah.
emerging trends, and the growing demands of our interconnected world.
Yeah, that's a great point.
So as you continue to, use and interact with network, just remember the incredible complexity and innovation that's happening behind the scenes.
Well said.
Thank you.
And on that note, we'd like to thank you for joining us on this deep dive into advanced computer networks.
Yeah, thanks for listening.
We hope you enjoyed the journey.